it's the history of the internet, which is just messy decisions compounding upon each other that no one can upset, right?
Hello, welcome to Security, Cryptography, whatever. I am Deirdre.
I'm David.
Hi, I'm Tom. I'm at Fly.io.
I am a cryptographic engineer at the Zcash Foundation.
What is my background?
That's good enough. It's good enough for this one.
I got a PhD in kind of cryptography from the University of Michigan a few years back. I also started the company Census, and nowadays I'm at a company called NameTech.
Cool.
I live in Denver, but I did 10 years in Ann Arbor.
Hi, I'm Ryan. I'm at Google, but as usual for Googlers, I'm not talking for Google. I'm just here talking.
Deirdre, David, we have Ryan Sleevi on the. I don't know if you realize this, but Ryan Sleevi's on.
Okay.
This is amazing,
and it's crazy because we get to see Ryan's smiling face instead of a picture of his dog.
I can't tell you how much time I've spent trying to find any picture of Ryan Sleevi anywhere. By the way,
I first met Ryan at Real World Crypto in 2016. We'd emailed a bit before then. But I'm pretty sure I talked to you for 2 minutes before I realized that you were Ryan Sleevi.
Yeah, that sounds about right. I'm surprised. I'm like, there's pictures of me out there.
Yeah, they're all karma.
Oh, wait, no, I took them down. That's right.
I'm going to stroke Ryan's ego a little bit because we're all very excited to have Ryan Sleevi on the podcast because Ryan Sleevi is basically a Batman of the web PKI. Like, he does the dirty work in the shadows that you may not see to keep everyone safe. And he may or may not be a vigilante in the way he goes about it. Confirm or deny? Are you Batman?
You've never seen me and Batman in the same time, same place.
There you go.
So, yeah.
He is the hero we need, if not the hero that we want.
Extremely that.
Oh, man, you guys are really stroking that ego here, right? All right.
Ryan, can you give me a capsule summary of the role that you have where you're in every conceivable security standards group I can imagine reading?
Oh, no, not anymore, right? That's the mistake I made when first coming to Google was my nuclear project was, hey, you should get involved in these standards groups. That's a good place for a new employee to start with. And you should work on this web crypto API. You know crypto.
Oh, poor thing.
So that was some fun starter projects. So I used to be more involved and have mostly backed off. But yeah, at Google, I mostly work on certificates at large. I came in to the Chrome side after like 2 years of doing open source contributions to it. And that was mostly because I couldn't get Firefox to build at the time. Firefox has done a lot for their build system, so credit to them. But, it's if you want to contribute to open source, you got to first figure out how to build it. So yeah, I came in working on smart cards at the time and then just sort of branched into a bunch of things because certificates are everywhere. And yeah, so the standards, you saw me in a lot of standards at the time because it was that starter project of, you should go get involved in standards.
Adding to my list of topics for today would now be web crypto.
Oh, God.
We should talk a little bit about web crypto.
Oh, God.
Oh, man, the stories I can share and the stories I can't share. Fun time.
Zero.
In this podcast, we're mostly interested in the stories that you can't tell. So just like...
Right, exactly.
No one will hear this. This is a safe place. So, Ryan, let's start here. Can you kind of explain succinctly what the web PKI is and what people kind of don't get about what the web PKI is?
So, yeah, I'll give you the succinct answer, but there's also a non-succinct answer. So I talked a little bit about this at IETF 109. So there was a presentation in the security area group that, I was lucky enough to be invited and that sort of talk. And that was my first time trying to really crystallize the definition. There'd actually been an IETF group that was chartered called like Web PKI Ops. And it probably comes as no surprise that after like 2 years of discussion, still couldn't come up with a succinct definition of what the Web PKI is. So, here where I'm invited, I get to make up my own definition. And so the definition sort of that I offered is the Web PKI is the PKI that is the set that is interoperable within web browsers. And I realize that feels like a sort of cheap definition, but as I talked about in the SAG talk, there's a lot of different PKIs, and there's this notion of, say, very early on that this would be like an OS service or a system-wide service. And that's not what we got, right? What we had was Netscape shipped SSL, they shipped a PKI, and IE quickly fast followed. And these are both sort of browser things. And we've gone through, there's, been a few decades of excitement, but we've really circled around back to it where the web PKI is the set of CAs, the set of policies, and the set of implementations that are really tied to sort of web browsers and web browser capabilities. And that's, the obvious players here, Safari, Chrome, Firefox, Microsoft through, IE and Edge. Obviously, Apple and Microsoft are at a little weird place because they have this as like an OS service, but then they also have stuff that they do in their browsers where they impose extra policies. And so that sort of concept of the set of CAs and the set of policies they have to adhere to satisfy browsers sort of fits as the web PKI. And that's, I guess, sort of similar to talking about standards groups now, like the WhatWG exists, which is a bunch of rendering engines working together to develop the HTML living standard. And that, really reflects what browsers ship, right? Not an ivory tower imagination of an XML-based markup language, but the reality and the messiness of error handling and edge cases and all the weird grotty bits in HTML, WhatWG and the HTML living standard. So you can sort of think of like web PKI as like a browser PKI living standard. It's that evolving
And
thing.
just to clarify,
how does that work for
what
you?
is a PKI in the first place?
A PKI is a great way to soak up venture capital funds, or at least it used to be. Man, oh man, PKI was the Bitcoin of the 90s.
Public key infrastructure, right?
Yeah, you're with the honest answer. Yes,
just
exactly.
about making sure that we're all agreeing what these acronyms mean.
Yes, yeah, exactly. And so there's a messiness, right, in that term, because like you could argue that Kerberos is a form of PKI, at least when you throw in some of the messy bits. And I know it's mostly secrets, but yeah, the PKI, when we usually talk about it, is referencing the certificates and X509 in particular, and usually for almost anyone sensible, with reference to like PKIX, which is RFC 5280, which is like a subset of what the telecom industry called PKI into the sensible thing that the internet calls PKI.
And like, as you described it, I think you could kind of get the impression that like the governance of the web PKI, that people like, so if the web PKI, the most important product of the web PKI is the set of certificates that your browser will trust, right? Like you could get the impression from that description that the web PKI is governed by Google, Apple, Microsoft, and Firefox, right? But that's not, is that really the case?
That it's an interesting case, right? I think there's an element there that the set of CAs or certificates that any browser trusts, right, is really like a product security question. And that's, not to wax too political on browser discussions, but we see that like in other browser features. We see Firefox not implementing this feature, or Apple raising privacy concerns with this feature. And we don't really talk about, Apple governing the web, but we talk about them making a security or privacy decision for their product and for their users. And I think there's an element of that, when we talk about web PKI, but there is also this element, which is that any browser, interoperability is a huge part of browser stories. And when it comes to like these features, if a browser doesn't implement a feature, if it's a good feature, they'll find that their users want that feature. They'll ask for that feature. They'll demand that feature. And I think that's something similar sort of when we think about web PKI is, the browsers are trying to balance the security needs of their products, security needs of their users, but also come up with interoperability. And that's where I think like groups like the CAB forum sort of come into plays to make sure that, when we make changes to our products, that they actually end up being interoperable and good for
and
users.
What's the CAB forum?
Yeah, exactly. I'm just throwing acronyms out left and right, just not expanding. That's the CA browser forum. And so the CA browser forum is pretty much just a discussion group of CAs and browsers, and it has its own storied history that I'll save you. But yeah, it's mostly just a bunch of mailing lists and periodic meetings. So similar to the IETF, except unlike the IETF, we don't really develop standards.
I was about to ask, like, is there anything binding in anything that happens on the CAB forum? It feels like it's binding, but it sounds like just kind of everyone collectively kind of agreeing if someone's been bad or not complying or not.
Oh, not even that, right? The CAB forum doesn't even agree on like badness or goodness. So yeah, there's nothing binding the CAB forum. What the CAB forum does, and it exists for some really funny logistical reasons. So the CAB forum produces a set of standards that the most prominent of which is called the baseline requirements. And that's for server certs. And that basically is trying to capture, here is the absolute floor for what it means to issue TLS certificates that are going to work in web browsers. Web browsers are, of course, going to put their own policies for their product based on the security needs. So a good example is different browsers will turn off SHA-1 at different rates, right? And that's eventually makes it into the baseline, but at the time, it's different browsers moving at different paces. So the CAB form produces the set of standards, but the standards aren't, and I say like standards, it really just guidelines. They're not binding. But what they do is those guidelines then get worked in by either CPA Canada, as in like Chartered Professional Accountants and AICPA, into what's called Web Trust, or they get worked into a different group by ETSI, which is a European telecom standards organization. They take those guidelines and turn them into audit guidelines to define how independent auditors can use. So like there's this element of the baseline requirements that exist, but they mostly exist to support the development of these audit requirements. And the whole reason for that is if someone's going to offer an independent audit, and I'll get into that, like if they're going to offer an independent audit, there needs to be some sort of, broadly speaking, industry agreed term for what the audit criteria are. So that's what the CAB form produces, is this industry agreed set that can then be turned into auditable things by these audit firms. And I realized, like, boy, I just dove into some really messy, weird, like, it's the history of the internet, which is just messy decisions compounding upon each other that no one can upset, right? And like, or coming with big ideas that then they can never actually implement, like IPv6.
So to step back from auditing CAs themselves, which kind of implies that the CAs are a thing that need to be audited. Let's say this podcast is becoming a CA. Why don't you tell us what we have to do to become a CA? And also, what is a CA?
We're not, by the way, kidding. At the end of this podcast, we're going to set in motion the effort to create a new CA.
And not including logging into my Google Cloud account and spinning up CA as a service that Google just released.
Yeah. I mean, it's perfect because I know you had Filippo on a few episodes ago, and he went through that exercise of spinning up a CP log that he called behind the sofa. Because it was just exactly. And the question is, why don't you trust this log behind the sofa? Which is an excellent question. So to unpack, David's thing, which is, what is a CA? A CA is either a certification authority or a certificate authority. And this is one of those like messy terms that who really cares the difference, but you will find religious debates on.
I just saw someone ask this question like nonchalantly on the internet somewhere. I was just like, oh God.
Yeah.
Let's talk about tabs versus spaces next.
Oh my.
Yes, it's right up there. And at the end of the day, the CA, whether you expose that as certification or certificate, they produce certificates. And a certificate is this overly complex, terribly designed, very archaic form of binding claims with cryptography. And, you had that fun conversation on GWTs that stick it in JSON, and certificates just stick it in ASN1, which was the 1980s way of passing things around, designed by the telecom firms. And I keep mentioning telecom, because there was an interesting set of constraints, but it's also not the best technology stack to come out. Like, we don't talk about the OSI model much anymore, and there's a reason for that. So, a CA is just someone who mints certificates. And in the case of web browsers, really what we're looking for a certificate is to match a domain name with a public key. So that way we know how to establish an encrypted connection to it using TLS, right? So I'm, hand waving, oversimplifying. So what does it take to become a CA? And that answer has, gone through some fun changes over the past few decades. And I guess I pose the question to you is, David, who are you? Why should I trust you?
Sell you a certificate for $1,000. Tom can't watch though, or he has to pay $100.
Boy, yeah, that's tempting here. I should make you a CA because you'll sell it for $1,000. Well, I'm sure Deidre would sell it for $950. So why shouldn't Deidre be the CA?
Because I'll sue her. I plan on maintaining monopoly.
Mr. Lebowski.
All right. So, the how do you become a CA is really the core question that, and I guess I should jump into a term before I really answer that, which is just like, we've talked about browsers and CAs. Really, we call this collection of CAs and a set of policies like a root program. So, there's a Chrome root program, there's a Mozilla root program, and it's the collection of CAs they trust And if we think about CA as the organization or CA as the certificate, that definition holds, because a single organization may have many certificates, but they're all part of the same organization, or they might just have one. But a root program is like the collection of certificates, the collection of the policy, and generally the implementation of the software that uses those certificates. And so if you want to become a part of a root program, the question for pretty much every root program is why? What are you trying to do? How does this relate to my use case? Why should I trust you?
Let me ask a question real quick.
Yes.
If I took the names of all the current CAs that are trusted by the Google root program and put them in a hat, and I stuck my hand in and pulled one out at random, and I asked why, would you be able to tell me?
I could tell you in the abstract, depending on who you picked, I could tell you specifics. But so there's in the Google root program, I think it's about 57 organizations right now. A bit more number of certificates, but about 57 organizations. And that number, the reason I don't have that exact is it ebbs and flows with mergers and acquisitions or new programs coming in.
Quick question that you don't have to answer if you don't have to. If you get hit by a bus, is that knowledge just gone for Google and their root CA program? Or is it only partially gone? Because some of it's written down somewhere.
It's only partially gone. So David, worked as an intern on the team for a while.
Sleevi reviewed all of my code when I was an intern, which is weird because he wasn't at all in the hierarchy of where I was working.
Yeah. So we have a team, and in fact, we're hiring for the team, and we've hired and bringing on board a number of folks out of our Washington D.C. office. So I was tweeting about this a few months ago, and I'm really excited because we do have a growing team. But yeah, even at Google, they're the bus factor, or Sleevi wins the lottery and decides to go off somewhere fun and relaxing. There's definitely some robustness, but David also knows that I have a penchant for recording useless trivia, and just bringing it out at the worst possible time. So there is going to be a loss of pedantry, but I think people would call that a win, not a loss.
Yeah, the team that you're talking about right now, you're talking about the team that manages the Chrome root program, right?
Cool.
Okay,
that's correct.
We're dancing around it a little bit, right? But what we're essentially talking about is the set of CAs that will be allowed to issue certificates that Chrome will trust, which is a huge fraction of the internet, right? So right there's an immense amount of power and control over, not just who's allowed to be in business doing CA stuff, but how they're going to behave and comport themselves on the internet. And we can probably think of horror stories from the last 15 years or 20 years of, people doing just batshit crazy things with their CAs that we all are glad that they don't get to do anymore, right?
Negligent things.
A question I'm super interested in, and an opportunity to sell your role. What's the roles that you're hiring for? Is what's the day-to-day of somebody working on that team? The people that you're hiring, what's the work that's what does that look like? We're pretty technical. I mean, we're also kind of dancing around the fact that I think most of us know a lot of these terms, and we're just trying to do a better job of explaining them to people that are listening for the first time. But I'm genuinely curious about when I come in next Thursday after I take a job in the Chrome root program, because by the way, that sounds awesome to me. What am I doing?
Yeah, so we have a couple roles, right? We've got some folks who are focused, heads down on engineering. So I can talk a little bit about the engineering that's happening now and the engineering that's coming. So right now we are launching, work. I'm saying we here, and I now have to correct myself, right? Because I said I'm not speaking for Google, but Chrome is working on this, and this is all public, right? Chrome's working on launching a cert verifier. And the reason for that is it currently integrates with various OS cert verification stacks, which means you get a different behavior on Chrome on Windows versus Chrome on Mac, and you'll get different errors and different messages and all sorts of unpredictability, which is terrible as a web developer, because the whole appeal of the web is write once, run anywhere. It's Java but without Java. I mean, it's JavaScript though. So
you're talking about cross-platform taking ownership of how Chrome-related products validate certificates instead of delegating it.
Exactly. So there's consistent performance and consistent characteristics, whether you're on mobile or desktop, and that you can debug and understand what's happening. And so you can make sure that your websites work everywhere, which is great. And this is something, right, Firefox has always had, because that's just, they always had it. They never integrated with the OS, which is why they were loathed by IT admins
Firefox
everywhere.
uses NSS, if I remember correctly.
Yeah.
As their verification stack.
Yeah. And NSS is, strangely enough, I learned, part of the Linux standard base, but in theory, How often distros ship it? But yeah, Firefox ships their own copy of NSS. They ignore the LSP version. They ship that cross-platform. And of course, other browsers generally have not concerned themselves with cross-platform behavior. Like Safari on Windows, not so much a thing now. You're not getting as much core foundation on Windows as you did in the iTunes log.
And it's been a while since I looked at that code and said I liked it, and then a million people dunked on me for saying I liked NSS. But NSS is basically a competitor to the TLS bits of OpenSSL, right?
Yeah,
exactly. So NSS came about because at the time of Mozilla's creation, so we had Firefox from Netscape, and then Netscape Navigator, and then Mozilla open sourced and is the open source foundation. We have Firefox that came out of the open sourcing of Netscape, and leading a whole bunch of history on that. And the issue was they could not release the source code for the crypto bits
because of export.
Because crypto politics was a big part of it at the time. This was, if I recall my history correctly, around 2001.
Export controls.
And so there was actually a discussion of Firefox, the new Mozilla Firefox using OpenSSL as the basis of its TLS stack and certificate verification stack. And eventually Netscape was able to get those bits open source for the crypto, and that became Mozilla NSS, Network Security Services, as a library, which had previously been part of Navigator. So yeah, it exists more or less as an alternative crypto stack. And, OpenSSL has a TLS library, it has certificate validation, it has low-level crypto. NSS similarly has those concepts. I will mention though, like NSS has 3 different completely independent certificate verification stacks. The one that they originally wrote for Netscape and the way beyond, so what is known as legacy. And then a bunch of grad students decided to convert Java to C with exception handling using macros. And this became what's known as libpkix. And so libpkix is like 6 layers of C macros that exist to emulate Java behavior in C. And this is what Chrome used for a long time on Linux.
This is why NSS is better, is because you have options.
Right, exactly. And Java code in C, what could go wrong? Exception handling through macros, what could go wrong? And now Firefox rewrote their certificate verification stack a few years ago, and they call it Mozilla pkix, and now this is also part of NSS. Sorry for that, otherwise boring history thing, but there's so many ways to verify certificates, and each one of them have different behaviors, policies. But we were talking about root programs. So stepping way back there's an element that certainly says, the decisions Chrome makes on what CAs to trust or not trust, has an impact on users. But certainly over history, the decisions Mozilla makes has been far more impactful, just because of how many open source projects derive their behavior from the decisions that Mozilla makes, as well as most Linux distros, right? Most Linux distros have something called a CA certificates package that they ship, which more or less says, well, Mozilla said it's good, so Mozilla's the open source golden child, and therefore we don't have to think about it.
That's so wild that's like an influence of open source that I wouldn't even have thought of. That like, just because this is an open source way to verify certificates and you can see how you do it, it's not just sort of like prodding a black box, that everyone's just sort of like, do what they do because we can see what they do and we can't see what other people do.
Yeah. And you hit on a big point there. And one of the reasons that so many folks look to Mozilla's root program, one, there's the element of the code, but the other part is Mozilla has always been very open. And so their policies on sort of what CAs do we trust and why do they trust CAs has always been very open. I shouldn't say always, because since 2006, which in tech terms is practically always, has been open. And so, the question, going back now to the question of what does it take to become a CA, right? And the Mozilla model is really one to look at. And if you follow the Mozilla model, you're definitely rising to one of the higher bars out there. And so the Mozilla model, right, is the first thing you have to do is you have to create your certificate. What is the thing that we're going to trust? Well, you have to make up your cert. And the thing about, I mentioned the baseline requirements in the CAB forum. Many root programs have incorporated the baseline requirements as like, this is you must be this tall to ride. So even though the CAB forum product isn't binding, products incorporate that into their own requirements and make it binding. So when Mozilla says you must follow the baseline requirements, now the baseline requirements are binding. If Mozilla didn't say that, like you could do it. You could not.
Yeah.
It's up to you. Whatever, man. A sign, not a cop. Going back to creating a certificate, the baseline requirements say you have to get a bunch of auditors in a room to witness you birthing a key from nothingness. And you have to birth a key from nothingness onto special hardware. And, the baseline requirements required has to be a FIPS 140-2. Yes, it says -2, not -3, but a FIPS 140-2, certified device. And I say certified, and anyone who's worked with FIPS know I'm just making up words here. But you birth the key onto hopefully something that is not going to just spit the key out to anyone who comes by. And your auditors witness you birthing this key because you followed a ceremony with a script. And once you've done all these things, you have this new key that is born, and then you can create a self-signed certificate. And now, congrats, you've created a root CA. And the idea here is from that moment on, you need to play by the rules. And you have the auditors come back at a later point to make sure that you've been playing by the rules. And the idea of why am I talking about auditors? Can't you just trust me to play by the rules? Is because I don't trust you just like you said you did something. Why should I trust you? The idea of auditors is get an independent, hopefully neutral third party to come in. Look at what you're doing, what you say you're doing, and look to see if you can provide evidence to actually say that to actually show that you did what you said. And they work from the assumption that whatever you say you're not doing until you provide enough evidence that convinces the auditor that, you've probably done what you said.
In North America, that audit process is basically web trust?
Yeah. So in North America, it's pretty much web trust. And most of the world, it's web trust. And that's a standard developed by CPA Canada, AICPA, that, which are the two, it's the Canadian and American professional associations for chartered professional accountants. But then there's an international standard that allows other countries to use those guidelines, and that's called ISAE 3000. And I can save you a bunch of audit terminology, but the idea here is that professional auditors in whatever their appropriate jurisdiction, can produce these reports. And what that means is, like, David, you could declare yourself a web trust auditor and say, I'm just going to make web trust reports. And if you want to do that, you have to go get licensed by AICPA or CPA Canada if you want to use their terms. And so that's the sort of catch-all is web trust provides a licensing for that.
How hard is that licensing to get?
I was going to say, who wants to go get certified?
I'm licensed as a convenience store in the state of Michigan. That's actually true, but that was a pretty easy one to get.
This is our new plan. We've gone from creating a CA to creating a new web trust auditor. This sounds much more interesting.
No, we're going to create both. That saves a lot of money long term.
We're going to have David certified that we are up to code CA.
Right, exactly. As long as, David can assure us of the independence and neutrality, why not? Yeah, so there are licensing fees that web trust runs. And this is one of the interesting things that has changed over, say, the past decade is it used to be a lot easier just to become a web trust auditor to, pay the fee. And if you were one of the big four firms, you could sort of pay the fee once, and then all of your branches in every country can just get covered by that fee, whether or not they necessarily had the professional skills or understanding for what it is they were doing. The fee was the fee. And web trust, CPA Canada has recognized that, hey, there's some brand damage coming to the web trust brand. If just anyone can become a web trust auditor, we should care a bit more. So you need to be a professional accountant, but that's also not the most difficult thing to be. And go through your CPE courses the same as you would for a lot of other professional things, and then you can become a web trust auditor.
Good. I spent a big chunk of my career, quote unquote, auditing software for vulnerability. So I would imagine when you say a CA gets audited, right? A lot of us would have a conception in our head of oh, well, they're sending a team of technical people out to look for vulnerabilities and gaps and things like that. And, those people understand cryptography and things like that. Is web trust is there a place where that comes into play? Are there serious penetration tests and audits and things like that, or?
Generally, no.
Oh boy!
Right. I know. Just the answer you wanted to hear.
For us, yes.
So,
but also given a decent technical standard, a large component of this is non-technical rule policy that needs to be followed. Right, the fact that only not anybody can just walk up to the HSM and issue a new certificate is something that, no matter how you swing it, is going to have a large organizational or physical component to it.
Yeah. And I guess the no is more to Thomas's question of like thinking about it as pen test or security audits. The history of web trust, and I gave a presentation to the CAB forum about this, I guess a few years ago, that actually looked through the whole history of these audit standards. Where did they come from? If you've ever worked for, say, like a company that has like a SOC audit, right? Oh, I've got my SOC 2 audit, which looks at this notion of what they call principles and criteria, which are very abstract things. That's why they're just principles. Do you handle things with integrity and confidentiality? Well, that's a principle. What does that actually mean? And the idea here is you write criteria that says, like, this is what we specifically do. And then the auditor assesses whether or not you actually do that. And so it's a bit more of I don't want to say like a documentation exercise, but that is a huge part of it, which is saying, like, here's how we meet this abstract goal. And then the baseline requirements and the web trust standards that are derived from the baseline requirements actually do, as David was saying, have a number of very specific sort of technical requirements. And then those have to be mapped in. But you're not necessarily going to see, say, an audit firm doing a pen test on the system. What they may check, though, is, what is your patch management strategy? And do you have evidence that you're actually following that patch management strategy? So rather than doing the pen test to see, are you running the outdated version, they may look at, show me the evidence where you applied the fix for this version. And so it's more like those type of audits, or an ISO 27001 audit, than it is like a code audit or security assessment.
I'm cursed to like be the voice of Hacker News in this this weird podcast we have, right? Because I've had this discussion so many times there, right? So like, I think like a burning question that people have about this stuff is like, if you're a technical person and you're thinking about CAs, like a big question you have is just like, what are the inadvertent technical mistakes that they're going to make that are going to compromise the security of their CA? Kind of like the big thing we're worried about here is like misissuance, right? It's the idea of like, you issue a certificate for, Google and you're not Google, right? Is there a process by which like the CA software that you're running, your ACME implementation, or like how you're doing DNS lookups for, domain certificates and things like that? Is there a place where the certifying process for the CA gives you any kind of confidence that people are technically on the ball?
Oh man, you get into one of my favorite topics here. Boy, this is an area where I think a lot of browsers have given feedback, and we've talked a lot about web trust. There's of course this other audit standard, ETSI, and again, like pointing to public comments, but not speaking on behalf of Google. But the Chrome root program actually is very explicit that it prefers web trust over ETSI and may discontinue ETSI at some point in the future. And that's because what you're getting to is how much assurance does the audit process, the auditors, the audit skills, how much does that match with what you care about as the end user, right? As the end user, you're like, I want to make sure there's not a google.com certificate issued to someone who's not google.com. I want to make sure their HSM is not just blasting, the private key over the airwaves to anyone who's going to listen in. Or I want to make sure that they have not stuck the HSM under someone's desk, which a CA did. In fact, multiple CAs have done. Like, oh yeah, we just put the private key under someone's desk, and oops, like there was no physical security.
They could just walk away with it.
No big deal. Yeah. If you look at the discussions around removing trust in Symantec, one of the audit reports noted that one of Symantec's sub-CAs had no real records around the physical security of their private key, and they had just as much capability as Symantec for issuance. So, to Tom's question, like, should you feel confident in the current audits? The answer is you should look at it with a healthy dose of suspicion. You're like, I don't know whether this is going to make you feel better or worse, but a vast majority of CAs run like EJBCA, which is the Java CA software that is everything and the kitchen sink all in one, because it is the CA software that you use if you're running a production line and you want to, stick certificates to show this is a legitimate device, or you're issuing employee certificates. Like, it is the certificate Swiss Army knife, which is both to their credit and like, if you think about Heartbleed was taking the kitchen sink of crypto standards, just putting them all in OpenSSL. EJBCA does have that reputation of they'll implement anything if you ask, and particularly if you're a paying customer.
Google has some kind of hardcore technical audit requirements for some things that they do, right? Like I could think of at least one of them where there's like a specific set of fairly hardcore pen testers that are the only people allowed to certify, right? Could you guys like tomorrow come up with a criteria for like, okay, from this date next year, you have to be audited by one of these 3 firms that know how to audit CAs. And if you're not, then we're going to distrust you. Could you guys just do that by fiat if you wanted to?
The question that's interesting that you get to, I, again, not speaking for Google when you talk about the you guys, I know our PR person is going to make sure I said all these disclaimers.
We're all adults in here.
So, you're describing what is common at a lot of firms, like vendor security audits, right? And you'll see this at a lot of tech companies, right? If you're going to say use Slack as your chat app, in fact, there may even be requirements like imposed by legislation that you have a vendor security audit process where you, as the one who's going to use Slack, you need to do it and assess how well Slack does. And, Slack will provide you a bunch of standards and say like, oh, look, we comply with these standards. That's why you can trust us. And then the vendor security auditors will say, okay, well, you've got these standards checklist and you gave answers that did not scare the bejesus out of us to our questions for the things we care about. And so we're good with it. And so that is, I think, a big element of what becoming a trusted CA. And really, when we talk about trusted CA in a root program, it's similar to the parallel I draw for browsers is imagine your browser is going to ship a third-party extension by default. What would it take to ship that third-party extension to every one of your users? Or if you're Microsoft, right? What would it take to bundle a piece of third-party software shipped to every one of your users? What are the things that you need to make sure of before you ship that to all your users? Now, users may go install software, they may go install extensions, and they may go install CAs. And at that point, like the users made a decision, you can lead a horse to water, but you can't make them drink. You can't really make sure users are going to make the best decision, but you can do your best to help them. But when it comes to things that you were shipping pre-installed, right? When you go download Chrome or Firefox or Safari, or really in the case, Mac OS, what's it going to behave like out of the box? And what's the step in by default? So you absolutely could. And in fact, that's what root programs have increasingly shifted to. So Microsoft has announced, for example, that they require a bunch of due diligence on the beneficial ownership of CAs that are in their program. So it used to be that, well, you incorporated somewhere, right? And you filled out some paperwork and you told us you want to be a CA. Now Microsoft requires a bunch of due diligence and works carefully with their legal team to actually check through that ownership. And you have contracts. If you want to become part of the Microsoft root program shipped for Windows, you need to execute a contract with Microsoft. And that goes through, all of the legal contracting process with that. And that contract is lovely because it has some lovely teeth and penalties. And what happens if you decide you don't want to become a CA tomorrow? Well, guess what? Microsoft still has, powers for that contract because you don't just get to unilaterally walk away from the contract.
Does Apple do that?
So Apple's not yet. And in fact, Microsoft is the only one that currently has contractual requirements. And that's something that other root programs have discussed. I guess it doesn't really come as much as fries, right? When you think Microsoft, you think lawyers. So it works. And it's really smart for them. If you think about the risk profile for Microsoft as well, it's smart to have this contract.
It's Mozilla, Apple, Microsoft, Google, right? Like who's the 5th important root program?
Amazon. AWS.
Amazon doesn't have a root program, do they?
Oh, they don't ship.
So historically, you had Oracle in play because of Java. You had Adobe in play because if you're doing anything with like document signing certificates, but Adobe also, because Acrobat, of course, can make TLS connections in your PDF. It has a TLS root program in there. And for Java, of course, you need a root program for there. Those are the main ones that stand out and come to mind. You do have smaller programs that depend on different use cases. So for example, for a while, the Wi-Fi Alliance had a root program. If you don't know the Wi-Fi Alliance, they are the ones who, will give you a certified Wi-Fi Alliance sticker that says you can implement Wi-Fi standards correctly. But they also worked on standards to allow you like hotspot roaming. So they have this thing called Passpoint, which allows you to roam from different Wi-Fi networks that may require payments. And so they have a root program for Passpoint that talks about like, what are the Wi-Fi Alliance CAs that you're talking to a Wi-Fi Alliance hotspot, and then you can do this network handoff or give money to whoever the network
I feel like I have this impression that like, there's a lot of things that Google would do. Let's say for the rest of the conversation, let's just say that we're speaking for the Adobe root program, right? But there's a lot of there's a lot of things that the Adobe root program would do if they could just do whatever they wanted by fiat, right? But that there's a sense in which the CAs have kind of a veto on things. Is the sense like I'm probably wrong here, right? Like I just followed the mailing list, right? But like I feel like there've been like discussions or something resembling votes on new BAR requirements, at CAB Forum and things like that, where like you have not reliably gotten your way, which is a tragedy, by the way. You should like I'd happily sign the thing that just gives you control of all this stuff. But
yeah. So there was a really lengthy discussion about exactly that point in the CAB Forum around this ballot that was known as SC31. So SC31 was called the browser alignment ballot. And what it tried to do was take existing requirements, some that were decades old from different root programs and bring them into the BR. Because if you think about it, right, if you're a CA and you want to issue certificates that are going to work in web browsers, you don't design just for Chrome or you don't design just from Microsoft. You really want them to work everywhere because that's your whole selling point to customers is our certificates work everywhere you want to be, right? Lisa will come after you if you say exactly that, but close enough. And so the goal of SC31 was to actually bring those requirements into the baseline requirements, and it turned out to be rather controversial because there were some things that CAs didn't like. The root programs were already imposing, but that CAs felt that were unnecessary. And so there was this lengthy discussion about like what is the role of the CAB Forum here? And at the end of the day is, if the CAB Forum, say, were to veto a bunch of changes to the baseline requirements, its relevance decreases. And that's true for any organization, right? If your goal is to produce voluntary standards and your voluntary standards are useless, everyone's going to ignore you and go somewhere else or do the other thing. So there is that. But equally, I think all browsers are concerned on wanting to make sure that one, they're doing something interoperable, and two, that they're doing something achievable, right? Like if a browser says, you must jump 100 feet every time we say jump, like that's really hard for a human to do, just naturally unassisted. You have to think about like, what's my 100-foot jump system? You have to start buying trampolines or bungee cords to really make sure that you can get that full 100 feet. And that takes time. And I think browsers and root programs are aware of that, right? And so there's always this balance here of finding what is the data to figure out what is reasonable and what is the balance for security.
Do you feel like generally like the root program itself, like the Adobe root program, anything it wants, it's going to be able to get, like just through the whole system, through all the layers of this, right? Like if I tomorrow walk in at my job at the Adobe root program and say, from now on, nobody gets to run EJBCA anymore, right? Like, could I do that? Or is there an organizational reason why I couldn't like reasonably, add a requirement like that?
It's the game of asking the Adobe root program manager, what's going to happen if no one listens to you, right? Are you prepared for the consequences of that, right? And that's always the challenge for making any changes in an ecosystem, especially a multi-stakeholder ecosystem, is if you're going to say this certificate is not going to work in your product anymore, are you prepared for the consequences of that, right? And the consequences, I like users can't access the site. Are users going to start using other software? Is that something that you care about? Or if it's a paying customer, right, is your paying customer going to get upset? So there is this element of, and this is true though with any software change, right? Like if you decide, Fly is going to massively, change how its APIs behave, and suddenly every one of your customers is going to be broken. You're going to have a bunch of cheesed off customers and probably won't be customers for very long. And so that's the, tension is you have to figure out how to balance that. And for a browser, the concern of course is always, am I going to break something? And so the balance, like how do you balance that? Well, you introduce requirements that have like a phase-in date. And you say like new certificates issued after Tuesday, assuming Tuesday is a reasonable date for change. New certificates issued after Tuesday have to behave like this. And that way, 100% of the certificates out there don't matter. Like they may not comply, but that's okay. They'll continue to work. But come Tuesday, everything needs to work. And so how do you pick Tuesday? You pick Tuesday on how well you think it'll be achieved that 100% of the new certificates on Tuesday will be meeting that new requirement. And you see like Apple does this with most major OS releases, right? They made major changes to their root program in OS 10.13 and then further in OS 10.15. And they said, here's in the case of Apple, the big controversial one in this SC31 with lifetime. they said certificates need to be valid for 398 days or less. And here's the definition of what 398 days, right? Here's the number of seconds in a day. Here's how you deal with leap seconds.
It matters.
And this is what time means, which are all
well, it
apparently
matters if you're
controversial things.
negotiating your TLS connection and your certificate and your local host is clock skew, and then like your certificate is, according to your skewed local clock, too old and it does not verify. And then you can't connect to, google.com or whatever. Google never has this problem, obviously, but there have been plenty of other websites that have had this problem.
Or imagine if you're a CA and you put in all that work to comply with the rules, and then it turns out you issued your certs for 398 days in 1 second.
Yes. With Apple's approach, right? They had the policy requirement, and then they also had the technology requirement because they expected, and unsurprisingly, as happened, CAs failed to implement the policy change correctly. And so they still had to take steps on the software side. Sometimes that works for policy changes. That doesn't always work. And so that's the balance. But, to Thomas, your question on like fiat, that's a big part, I think, of root program management and figuring out which is how to make changes that are going to improve the security of your users, be aligned with your product needs, your security goals, because these are ultimately, the set of CAs that you're bundling in your product are CAs that exist to help you achieve a product security goal. And you want CAs that are going to be aligned with that. And how much time do they need and how much time is reasonable?
Yeah.
And that's a big part of the CAB form.
You're not saying this and you're not going to say this, but I'll just express my opinion here that with probably just one exception, the CAs are a force for evil, right? Like they have a business goal of issuing certificates as cheaply for them as possible at the highest amount that they can issue certificates for, right? And that generally they're pretty obstinate about, imposing new requirements that would, make it safer and make it less likely that they're going to misissue. And that, there's a pretty widespread mistrust of the web PKI kind of as a result of this belief that the certificate authorities are entirely mercenary, and entirely resistant to, like, we know a lot more stuff about securing, networks and applications now than we did, 10 years ago. But I don't think there's a widespread perception that CAs have kept up with that. And part of that is also like, I think Symantec was VeriSign CA, right? Like that was the largest.
It was many
like,
CAs.
The brand name that I think everyone thinks about there, or maybe just because I'm old, right? But like VeriSign used to be the CA, right? Like that was where you got certificates from. And like,
you put your little badge in your web page because that fucking matters.
Yeah, you had VeriSign and you had Thought. And guess what? Symantec was both of them. They had acquired both VeriSign and Thought. You had the two OG CAs, right? And the context, right, is VeriSign was spun off from RSA as the original sort of holder of the patent. And in conjunction with several companies, Visa was one of the companies, I think Microsoft was another, as to spin out VeriSign and create this group to encourage and promote public key cryptography. If you wanted to license the patent for RSA, you had to include VeriSign's public key. That was the catch. And then Thought existed because, Mark Shuttleworth was like, hey, there's crypto export laws and it's hard to get strong crypto outside of the US. So we will create a non-US entity that sort of ignores the US restrictions. And so Thought existed to provide strong crypto outside of the US. And Symantec acquired both of them. So yeah, like, I don't know that I would agree with your assertion that CAs are necessarily mercenary or evil, right? Well, I think you are overlooking that there have been a lot of really positive contributions from CAs, right? And that I think there are CAs that are doing a lot to try to find the right balance, because you have certificates, right? And certificates are pretty much this, it's fungible, it's commoditized. Any certificate from any CA is just as good as any other certificate from any other CA, because they're all held to the same standard and they all provide the same assurance, which is a binding of a domain name to a key. And you've had it's certainly true that there have been CAs that have tried to distinguish themselves by saying we provide something more than that, right? And you have this notion of like EV certificates or extra strong validation. And at the end of the day, it's still a domain name and a key, and that's what matters to every piece of automated software. And so your only value proposition is to the non-automated stuff. And that's really hard to quantify if it even exists in the first place.
Let's Encrypt pioneered, quote unquote pioneered, at least seems to pioneer if you're just like a general developer trying to get a cert for your web application so that you can serve stuff over TLS. Does ACME so that you can auto-magically be like, here, I am hosting something on this DNS, and ACME will verify that you own and control this DNS location. Here, you get a cert for 90 days. And it's very automated, and it feels more like it's not just a bunch of humans just being like, yeah, it looks good to me. Like they can get social engineered into issuing a certificate for, mydomain.com or whatever. Is that accurate, or is that sort of being like, well, no, there are actually CAs who are doing stuff like that under the hood. You just didn't really hear about it until Let's Encrypt made it explicitly like, this is the whole point. We're trying to automate this, make it cheap, free, and this is how we're doing it.
Yeah, you had a lot. And so I think of Let's Encrypt as sort of pioneering the combination of a lot of things and really executing very well on the engineering side. But a number of these weren't very new ideas, right? So you had StartCom, which was an Israeli CA, and they ran the CA, Start SSL, which offered free certs, and you could get a free cert for 1 to 3 years, depending on sort of the types. And the cert was fully free. It wasn't necessarily automated. It did some weird stuff with client certs, and eventually StartCom sold themselves in a very sort of infamous debacle that later led to the distrust of the acquiring CA WoSign. But StartCom, was one of the free CAs. There were several other free CAs. Komodo, which has now rebranded the CA business into Sectigo as a new they spun it out. So Komodo is gone, long live Sectigo. But at the day it was Komodo. They also had free certificates out there, that predated it, and for 90 days. And there were several other CAs that would do 90-day certs. Now, for some of these 90-day certs, they wouldn't let you get new ones, or they wouldn't let you automate. So that was their hook. It's like, it's 90 days and it's extra painful. So you want to get and pay for the full cert. On the automation front, you had CAs like GlobalSign and DigiCert, and pretty much all the major US CAs and Intrust had automation portals. And in fact, the automation portals would handle a lot of the domain validation automation and plugged in with a variety of absolutely terrible protocols like STEP or their own hand-rolled protocol. But that works. Like if you were a Windows shop, say running Active Directory certificate services that speaks all these protocols, you could glue these two together, and you could get a certificate from GlobalSign from your ADCS domain controller, and everything just sort of worked, and it was magical. So they had like a big focus on automation, but they treated it more as like a service contract. And if you looked at Let's Encrypt combined them. And of course, even now we have several other free CAs that have done that. Bypass, a Norwegian CA, now offers free certificates and supports ACME. I think they're 6 months. Zero SSL, which is really just a rebranded or white label brand of Sectigo, also offers free certificates. DigiCert supports ACME for some of their other certificate types, not necessarily even the free certificates. You can use ACME plus a paid for certificate if you're looking, say, for DigiCert to provide support for those certificates. And, support for certificates is a valid thing. Let's Encrypt will not support you at all, which is why they wrote a lot of software to hopefully manage. But, if you're trying to support, say, older devices, a Let's Encrypt cert may not work. You need to figure out from another CA, and then you have to, of course, work with that CA to figure out what configuration and magic incantation is it going to take. And Cloudflare released a tool, CFSSL, which exists to help you understand that, hopefully to reduce the support cost. That you plug in a certificate, and they designed it for Cloudflare of, you give us a certificate, we'll try to figure out what the configuration needs to be to actually make the certificate work. Historically, that was where a CA support team existed to provide you that holding personal guidance for whatever software you're dealing with. So Let's Encrypt was useful for a lot of things in combining these concepts. And of course, ACME it's a standard that tries to do it simple, for some value of simple, but compared to every other certificate issuance protocol that's just this horribly baroque and complex thing, it's so much easier. And so, on the topic of certificate management protocols, when the IETF took on certificates, they always assumed they would have one true certificate management protocol. Like the idea was, this is easy. Well, 1, define the spec for certificates, and 2, we'll define a management protocol. And turned out like the management protocol took 2 decades more and a whole bunch of infighting later, and became tremendously complex. So at least they got
the format that certificates use, right? The actual, the bits and bytes format of certificates is X509 is the protocol, right? Is there any defense for X509?
Is there any defense for JSON? Is there any defense for
Yes,
CBOR?
to both of those, yes. I think I
know,
could probably give you like a one sentence defense.
Oh,
Well, I mean,
I'm intrigued.
JSON's really easy to parse. It's universally supported. It's a borrowed notation from a very popular language. It has a bunch of basic features that are like a good, like kind of common denominator for what people need for storing, bags of attributes. I don't love JSON, but like I can see why JSON kind of took off, right? And CBOR kind of responds directly to, okay, we have JSON and it's really verbose, right? It's JSON messages are really big and CBOR is a straightforward encoding of the same concepts. It would be like how I would. X509 is a lot more than that, right?
Yeah. So X509, right, is if you think of it, it is the schema, but then there's like a schema language that actually defines like how you go from a schema to bits on the wire. So, if you think of like JSON schema and JSON, right, there's X509, which is the schema, and then there is ASN1, which is the sort of how you turn this into bits on the wire. And there's specifically this notion called distinguished encoding rules, which is how you turn a particular schema into a hopefully unambiguous series of bits and bytes. To the thing of like what makes this valuable, one of the arguments against JSON, right, is it's untyped, right? It could be a string, it's a number, maybe it's a 2 to the 56, maybe it's 2 to the 64, maybe it's somewhere in between. Who are you to tell? Maybe it's 2 to the 53 in this implementation. This string, maybe it's UTF-8, maybe it's on ASCII. You don't know.
Okay, I can't give you an argument for JSON certificates. I would never do that, right? But for the existence of JSON, right? But there are other typed representations. Like even in the 1990s, we had XDR, which was a much simpler form than X509 or things like that.
True. Yeah. So the context here of that is, I don't know if I can give you a full-throated defense on why didn't we choose anything else. I can give you the explanation of how we end up with this mess in the first place.
Telecoms.
Which was X509 wasn't meant to be a schema itself. It was actually just meant to be a part of an authentication protocol to the directory. And the directory was this X500 notion of the true source of all names on the, that you could ever want to express. And we would have one ontology for naming things. And in the directory, you could authenticate using an X509 certificate. And this was as an alternative to password. So X509 was really it was a pluggable authentication model. That got completely bastardized and ripped out from the directory and, became what we know as certificates today because of work that was going in the IETF on like how to encrypt email. The directory used ASN1 because it was designed a lot by telecom. And what they were optimizing for was streaming processing. And that was their whole goal is we want to be able to take bits as they come in. We may not have all the bits we need, do something with it, in the buffer, and then get those bits out of the buffer because we've done the thing we've needed. And so ASN1, in particular, Bear has this indefinite length encoding and all these weird bits. And they're all designed around this notion of what telecom needed, which was to be able to do structure-aware processing of data, working on data flows without having to wait for entire messages to be delivered before they could act on it because they were constrained in memory, or, you don't want to have to buffer everything because that has lag and latency. And so that's how we got this mess is, even at the time, this was the best solution for the problem.
I think it's important to like separate like the X509 schemas from the ASN1 schemas from the DIR encoding. Like DIR encoding is really not bad at all. It's just like length type value basically with a little bit of bit twiddling.
Yeah, it's like protobuf, or Thrift or any of your other, TLV or PDU, depending on what you want. It's, which is as scary as dealing with DNS on the wire, right? DNS it's one of these wonderfully length prefix. And with most like length prefixed protocols, if you can't do math, then you can't do math and bad things happen. If if the inner number is greater than the outer number, bad things happen. You run off the end of your buffer. So, I mean, it's terrible in that regard, but you're absolutely right that the subset of AS1 that X509 uses is somewhat sensible, and it's the issues there are how do I represent this concept? What are the different ways of expressing it, and how do I pick one? And a lot of bad decisions were made.
Common names that get complicated, and what are those, and why are they like untyped compared to?
And these subject alternative names go in an extension. I mean, those are the real things
like
now.
The X509 generalized names, which could be anything. DNS names are IPs, but also just like an email address. Or I have a certificate somewhere that has a picture of Sleevy's dog embedded in the subject alternate name. That I was going to try and see if I could get a real certificate authority to issue.
We should put that in the show notes.
I think I've since lost that certificate. I'm pretty sure it was on my Google intern computer, which, as we learned in the previous episode, has since been co-opted to be used as a fuzzer.
That's right. Abhishek's grabbing all the intern machines. Yes. So I think, to going back here, because we've talked a little bit about root programs, and since I mentioned the directory, this is like one of those weird things that we're stuck with, similar to IPv4, similar to BGP. Like, oops, mistakes were made, but they're impossible to change because they're just so widespread. When all this technology was being developed, the idea is that there was going to be this directory protocol, which would allow you to bring different networks together and exchange information about the networks, and everyone could have your own little enclave, and you are the king of your castle, and you have control over your dominion. And so this notion of CAs, the idea here was, Thomas, if you want to say what certificate is for your name, the idea is I would go to the directory and I would have some uniquely unambiguous way to identify what it is. Like if I want to talk to Thomas's machine foo, I would look it up in the directory. And when I want to talk to foo, I would ask you in the directory, Thomas, who is your CA of choice, or what CA do you use to issue certificates for your things? And you would be, the sole arbiter of truth. Where that broke down, right, is the directory is really an alternative naming scheme to DNS. They are completely different naming schemes, because DNS is, there's the root zone, and there's com and net, and then, beneath com and net, there's google.com or sleevy.net. There's all these things. And so these concepts don't really map anymore. And so this whole concept model of X509 really fell apart, and Netscape did their best to sort of put it back together by saying, well, look, we'll just have CA, we'll pick the CAs that work in our software, and these will be able to issue for any name. And their choice of CAs was really what CAs are out there that users may want to have their certificates work with. So the selection of CA was really oriented around who has certificates out there that we want to work in our product versus whose certificates, who do we want to trust to issue certificates on behalf of our users. And so there's like this weird shift that happens. And my IETF talk goes into this, in the history, but this is where I think when you talk about CAs being evil or talk about this, I think really what we're seeing is there's been this shift of how we think about CAs, how we think about root programs, from how this 1980s model was to where we are now. Different groups have understood this shift at different rates, or they've understood parts of it, and they're all trying to adjust. Everyone is trying to adjust in the ecosystem to figure out, like, how does this all play? What does this look like? And so, as with a lot of computer security, where we are now in 2021 is vastly different than where we were in 2001. Microsoft got the SDL, and open source turns out to have won, but in a very weird way than I think how anyone thought open source was going to win. And there's been a lot of change for how we're thinking. And so now a root program is more an extension of product security than what it was originally, which was we would have the directory and everyone would have their own little enclave and authority zone, and everyone would be able to exchange. This is whatever CAs David Trust issue for, computers in his network, and whatever CAs Deidre Trust issue, for computers in her network. Now we have this notion of, well, these are CAs trusted to issue on the internet. And that's the shift. So that's where, like, of course, I'm not going to say CAs are evil, but I do think that there's been this change, and not every party in the ecosystem has really understood or fully grasped all the changes that are happening. And this creates like challenges. So like right now, the EU is proposing that the EU should be the source of truth for all trusted CAs for software anywhere. And so they've got this law that they've got this EIDAS, and they're revising this law. And part of this is trying to say that if you do TLS, you must accept these European CAs. And when I say these European CAs, It means any member state or anyone that the EU enters with treaty with can unilaterally declare this CA should be trusted for the internet. And then anything doing TLS needs to trust that. And they cannot reject certificates if they comply with the European standards. So you can't say this certificate's not trusted. You can't remove trust in those CAs.
This is like a way of saying that Luxembourg could issue a Gmail certificate.
Yes.
So Luxembourg, can we all just level set? Luxembourg should not be able to issue a Gmail certificate, right? Like, we agree on that.
Or if you look at the countries, the EU is looking at treaty with, right? They're having discussions with the UAE. They're having discussions with Thailand, with Vietnam, with Japan, countries that South Korea, Brazil, countries that have various interpretations on sort of how to approach encrypted communications. And the idea, if you're talking about identity, this makes sense. If you're talking about TLS and domains, this is perhaps a bit more questionable. And this is something that is actively being debated right now. The revisions that introduce this requirement are being proposed as law. And so they're going through like the European Parliament and European Council of Member States to be discussed and marked up before becoming final law. So we live in interesting times, but a lot of that model is based on that early 1980s assumption of every country would be sovereign for their country. And then in the US, every state would be sovereign for their state. And then every state could license corporations. And so each corporation is authoritative for their corporation. And there's like RFCs on like a naming scheme for North America for how you can address the Tide House, which is a popular Silicon Valley bar, or at least used to be. They shut down. I'm like, here's the one true name of the Tide House in the directory. And so if you want to get certificates for Tide House, this is how you look them up in the directory.
As a Irish citizen by birth, I am not in favor of this EU measure, and I'm going to write to my representative. That's how that works, right?
What are you talking about? Our podcast CA could become a fine European CA. That's what I'm hearing. We're premium.
You need to go incorporate in Luxembourg. And so, on that topic, Sectigo, I mentioned, right, now has a European arm in Spain, and they have now become, because Sectigo, I should say, is based in the UK. And so things are different now for the EU and the UK.
I'm sitting here Googling whether the Vatican is an EU state right now.
Oh. No, I don't think they are. I think the Vatican's the Vatican.
I'm Catholic. I'm going to go talk to my priest, see if I can get this.
Can get holy certificate.
Go ask the cardinal.
We could do away with all this nonsense, right? And just store things in the DNS. And just use the DNS as kind of a global hierarchical CA, like the internet is a source of truth, and no one would be able to charge for it because I guess the DNS is free. That's the DNSSEC, kind of promise, right? DNSSEC and DANE, which is DANE is the CA is the DNSSEC, hierarchy or whatever, right? It may come as a surprise to some people here, but I'm not a fan of DNSSEC. But
have they moved up from RSA 512?
They're on RSA 1024 now.
Oh,
nominally short-lived. So,
I've been kind of living in a blissful state of thinking that, Chrome at one point dabbled with DNSSEC, and Mozilla dabbled with DANE at some point. And there was DNSSEC code at Apple for a little while, and then all of that code went away. And so my general line on this is, it was tried and it went away and it's never going to happen. You could reassure me right now that it's never going to happen, right? So I can just keep telling people, stick a fork in it, DNSSEC is dead.
Boy, I wish I could. No, DNSSEC will not die. And in fact, if you think about it, we got this whole mess with CAs, and Netscape was very clear when they proposed this. And this was Kip Hickman was the main engineer on the SSL2 spec. And so there's an old Cypherpunks mailing list that was, very active at the time. And Kip really was not afraid to get his hands dirty in this list in discussing this. And it was very clear that if we had DNSSEC, Netscape would have used DNSSEC, but we didn't have DNSSEC. So they came up with this CA choice. Chrome certainly played with what was called DNSSEC stapling. And the idea here is you would have a short list certificate that would have a full DNSSEC chain as an extension of the certificate. And if you add that, then you could talk for whatever name was sort of asserted for it. And this was, Adam Langley's project. And if you've ever seen Adam Langley or seen his name around, one of the most impressive engineers that I've ever worked with, and just incredibly productive and proficient. So he worked with this. There were I don't think I would say that the challenges here were necessarily with DNSSEC. It's just turns out short-lived certificates are really hard to get right. As Let's Encrypt has demonstrated, it's taken quite a bit to actually get off the ground. I think Let's Encrypt was like 6 years in the making, something to that effect, from the crew responsible for it. And so it was one of those, if it's too hard to use today, why do we care around this code? I think as we look at, say, some of the balkanization going on, where we see some of these interesting legislative challenges coming on saying, like, you must trust RCA for the internet. DNSSEC has a lot of appeal because it is based on the source of truth in DNS, right? Like, if you're wanting to talk about sleevy.com, you're going to hit DNS. Anyone else claiming to be sleevy.com, you don't want to trust. And so it makes sense to get the records. The big challenges with DNSSEC beyond, as Deidre mentioned, that there's the crypto, which, okay, it's been weak, but is getting better, has just been that what's known as CPE, right? Consumer premises equipment, or otherwise known as home routers, is just absolutely terrible. And you use really crappy DNS stacks that are, decades old, because of course it's IoT. You're not a true IoT vendor if you're not shipping something that's already a decade out of date, and not providing updates for it. They would do things like just crash on seeing a DNSSEC record. We had on the Chrome side, again, like I keep saying but Chrome had this fun bug where the VP of Chrome's home router would crash if Chrome tried to make more than 6 DNS requests at the same time. Like, the whole network would crash. And so of course we sent multiple senior code engineers there, right? We're getting network traces and packet captures, trying to figure out, like, why is that when Chrome sends 7 requests, this thing flops over, but 6 requests is fine. And it was some old AT&T equipment, and it was brand new for them.
It had a max buffer of DNS record, and it was like maxing it out or something like that.
It had a buffer overflow in the DNS code that they patched. It was DNS mask with, a bug. And so, yeah. So I say this to not reassure comments, because I think that things like DANE and DNSSEC are actually are going to be pretty important, because DNS went through a lot of this geopolitical upheaval with the ICANN transition, when it transitioned from being under the Commerce Department to being under ICANN and IANA. And there was just a tremendous amount of political hand-wringing around that from, we don't trust the US government to operate this, but do we trust a California nonprofit, ICANN, to operate this? But it's mostly been settled. So there is some appeal of maybe DNS is the better place to put these keys for some of these problems.
I guess there's a bunch of things I'd say there, but
yeah, I know.
Two things I would zero in on, right? And the first is that it seems like, from a governance perspective, DNSSEC is even more, or DNS in general is even more tied to, local governments, right? Finland is the authority for, what records are going to be under the, the .fi TLD, right? But the bigger question I have, and maybe if you think that this is a realistic thing that could happen, that I assume you have you must have an answer to this, right? Is how do you deal with revocation, right? If some random CA right now issues a gmail.com certificate, my mental model is that you guys will, through a series of different, mechanisms, probably detect that and then probably nuke that CA from orbit. But you can't do that with the DNS hierarchy, right? There's only one of them.
So, yeah, I'm going to give you things that are going to keep you up at night, right? I'm going to give you the spooky scaries. So the example of Finland, right, controlling .fi, because they control .fi, they can get a cert for anything under .fi today, right? Nothing prevents that. They are the source of truth for .fi. They can get a cert for any of that. So it doesn't really change much from the status quo of what we have with CAs today. Is if a CA issued a cert to, and we'll just, I don't know who the .fi operator is, but the Finnish government sees .fi as sovereign territory. So whoever they pick to run .fi, let's say, they issue a cert. The CA didn't do anything wrong for issuing that cert. And in fact, there's no reason to revoke that cert, at least by all of the current standards today.
You could imagine a scenario though, right? You could have CAA records or something locking a particular major property down to, a particular CA. And that major property could have an arrangement with that CA saying, we're only going to issue certificates under, this process, right? It's not simply domain validation. We're doing something else, right?
Yeah, but .fi could change how that behaves, right? Like you set all those on your name server, the .fi would just say, oh yeah, this lovely domain you have here, Thomas.fi, we're just going to send it to our name server that doesn't have these CAA records. And then everything's groovy.
Yeah. Okay.
So that was the .fi case. The revocation case, I think is one because, I recently was tweeting out about what I called the fast fed and TLS security, which looked at this new protocol that combines OpenID Connect and several other federation protocols and tries to provide, one protocol to rule them all. Is revocation mostly doesn't work, especially though in non-browser sort of scenarios. So it really depends on your threat model here. If there's a, gmail.fi, or I think the interesting one to really think about is something like a GCP certificate, because that's the one that should really give you the spooky scaries. Because how often do you access Google Cloud, say in your browser versus say using curl or your server to server, stuff? That revocation is largely not going to work. Curl is not going to know to nuke that CA from orbit. And your Linux distro may not nuke the CA from orbit. Historically, the Linux distros would ship a year or 2 year outdated copy of the Mozilla store. So even if Mozilla moved, the Linux distro may not move. Or my favorite case was Linux distros that added back CAs just unilaterally. So there was this led to a fun discussion by Mozilla recently where Mozilla had, the semantic CAs that were in their program, and they eventually removed. They had code in their software in Mozilla NSS to not trust those certificates for any, certificate issued after a particular date, but they finally got around to removing it from their root program. And several Linux distros re-added the semantic certs back to their root program. And the reason was because Microsoft's NuGet, which is a .NET package management library, was using these certificates for code signing and was using the TLS root store for code signing. And so then they decided, well, this is going to break our NuGet packages on Ubuntu. So we're going to add semantic back to Ubuntu for all users. So, in your scenario here of a CA going rogue, the revocation that we might believe we have doesn't really work as reliably as you'd want. And in fact, if you did have DNSSEC or DANE, you would have a much more reliable signal for that because you look to see the fresh DNSSEC record. You still have TTLs to deal with, but that's a different problem, right? And then a lot of resolvers will cap how long they'll cache. And when I say how long, we're talking on the order of days, not weeks or months.
Can I jump in here and ask about pinning for applications that pin certs and keys?
Oh, yeah.
We're just going to spend 20 minutes dunking on everything, I believe it.
I mean, yeah. So pinning is particularly terrible. There are ways to do it right, but generally the way to doing it wrong is to say, I'm going to pin, I'm going to use, say, an OS root store, and then I'm going to restrict or I'm going to pin, I'm going to use a CA, and I want that CA to work in a bunch of different software, and I'm going to pin my software to it. And so this is an example of, say you have a mobile app and you have api.mysite.com, and in your app, you pin that API endpoint to a particular CA, but you have a bunch of other clients like set-top boxes or browsers or TVs, I don't know, that all want to access that site. It's a terrible idea because you're trying to say that this CA will work for all of my use cases in perpetuity. And if you're not the one who is actually making those decisions, the parallel that I draw is it's depending on an internal data structure of an opaque pointer. Oh yeah, offset 16 is always the reference count. I can always just add, take this void pointer, add 16, and then use that to mutate the ref count. No, it's an implementation detail. It's not part of an API. You're not guaranteed any of that. And pinning is a lot like that, where it's reaching it into an implementation detail. In this case, the implementation detail is a root program. And you're trying to say that this root program will always include this particular CA. And you're not guaranteed that. And the root program in particular doesn't guarantee that. The root programs have never, and if anything, the root programs of the past few decades have been trying to shift their clients away to understand that, look, any of these CAs you can get a certificate for. We will do our best to make sure that the certificate works for as long as it's valid, but we can't guarantee that. But we can't make any guarantees whatsoever, even after that. So yeah, pinning is terrible.
It's like an abstraction violation. You shouldn't even be thinking this hard about this certificate. You should just be trusting your root CAs to deliver you good certificates. And if they deliver you good certificates that validate to the root, then you're good. you shouldn't try harder to unwrap this onion and pin a particular cert and be in charge of it and all that sort of stuff. Yeah.
Or you just pin to a CA that you control and that, you exclusively control and make the decision. So, this is where for like mobile apps, if you really want that, and let's be honest, for most mobile apps, they're not doing it for security from network adversaries. They're doing it to protect the device owner from themselves, which I think is a bit of a dubious claim, right? Like, I can understand why Snapchat would do pinning. Like, yes, I get that threat model that Snapchat is, but I think it's a little dubious to try to, have an application that prevents the device owner from inspecting. That's a whole other conversation. But if you are going to do pinning, the idea here is you pin to a CA that you control, that you specifically control, and you're responsible as well for dealing with all the interop for that. So, it's not going to work in browsers because it's a CA you control, and that's an acceptable trade-off. So maybe you have one API endpoint for browsers and one API you're pinned in. With the semantic deprecation, this was something that a number of large sites went through, and you can sort of see publicly, like if you look at Netflix now versus where Netflix was at, they had one endpoint. Their web and TV and set-top boxes all used a common endpoint, a common set of API gateways. And so when browsers started removing trust in semantic, they had a bunch of set-top boxes that only trusted semantic. And so the solution there is you need different hosts, right? Here's the host for the website that give web-friendly certificates for web browsers. Here's the set of host for set-top boxes that gives set-top boxes. Here's the host for TV. And in fact, if you really take that idea to its logical conclusion, you start having a host per TLS set of capability. So, this device only has support for TLS 1.2 and VCAs. Like, it gets its host name, and this other device supports TLS 1.3. Give it a new host name, and they're all talking to the same backend, but they're
terminated at all these different ones that have different capabilities.
Exactly. Your configuration can match what your client capability is. So when you think about pinning is, the same as conceptually using a self-signed CA. And if you can accept that you're willing to use a self-signed CA for that case, and you're not going to get a bunch of complaints, then yeah, application pinning makes sense. But it has to be a CA that you're in control of and you're managing the trust for. And of course, how you manage that trust, there's been some great research by another former Chrome intern, Sasha Fall, who's looked at a lot of Android code and terrible pinning on Android. Dan Benet has, this paper, The Most Dangerous Code in the World, which is another, just great work looking at how many ways you can screw up pinning. And both iOS and Android have now offered APIs that allow you to do that a bit more safely, but you should only pin to CAs you control.
But so overall, to kind of cap off, do you think that things have gotten better over the last 10, 20 years? Like, as we talked a lot about the world changing and switching from the directory to where we're at now. And there's been a lot of improvements in the TLS space, I think.
Yep. Yeah. So, I mean, I think things have improved a lot. I think, when I think of like some of the major achievements, the fact that in the old days, and by the old days, I mean, really anything before 2015, which is not that old, you had just hundreds of organizations, each in independent control of CAs that could issue for the whole internet. As browsers started requiring that the baseline requirements and the audits and you actually checking the paperwork from CAs, a lot of that has gone away. DigiCert was really famous when they acquired the old Verizon CA, because Verizon had something like 379 organizations that all had keys to the internet, if you will, that were all unaudited and very dubious in quality. And DigiCert managed to sunset all of those by generally moving those CAs onto infrastructure that DigiCert controlled and made sure was compliant and audited. So, we have seen a lot of really substantial changes. We've seen the end for some of the crappier crypto. We've seen a lot of improvements around how the domain validation goes that I'd like to believe that CAs are still a weak link, right? We started off talking about audits and how, David, you can become an auditor yourself, just a little bit of CPE and I think it's like somewhere between 10 to 100,000 for CPA Canada, and Bob's your uncle. Yeah, then you can start auditing CAs, and then Deidre can start her own CA, and then the world becomes a much more interesting and exciting place. But, we have done a lot of that. I think where a lot of the work coming forward is going to be in improving these audits, because there's a lot of interesting stuff going on in the cloud audit space that I think is applicable to CAs. One of the things, like for CAs, is the current report is similar to what's known as a SOC 3 type report, where it's just like a 2-pager. Oh yeah, David's an honest person, Deidre's an honest person. She did what she said, but there's no examination of how you actually reach that conclusion. Like, what did you look at, David? What did you test? In cloud, there's generally more of a SOC 2 type audit, which will detail not only how Deidre's infrastructure runs, but what you looked at, what you tested, how Deidre claims she achieves particular goals, and then what you examined and whether or not Deidre passed or failed those claims. And maybe she failed some of them, but overall she still met the goal. It's just not as good as you'd want to see, but you can't argue that she's not there. Those are things that I think are very relevant to what we'll see for TLS. There's still obviously big gaps. BGP is still just a nightmare scenario for dealing with it. And there's not a lot of visibility into this space. There are BGP monitors, but figuring out how many certificates are affected, I'm not aware of folks actively monitoring that to say, like, this BGP hijack, these domains were pointed to IPs in this network range, and now we've seen interesting certificates and certificate transparency. The tools are there, the information's there, but I'm not sure that anyone's looking at that. So that's like an area. And of course, DNS registrar security is still not ideal. For DNSSEC, that is not as important, right? The registry security matters. The registrar matters because, sure, you can point the name servers, as I was telling Thomas, you can point the name servers to anyone and defeat a lot of these controls. So like registrar security matters, and there hasn't been as much improvement there. If you look on, say, the Mozilla forums, you'll see some ccTLD registries being hacked. You'll see registrar and account takeovers. I recently saw a write-up from Ian Carroll, who used to poke around the TLS space and is now poking at other things. Was looking at domains hosted by Mark Monitor, where he was able to potentially take over, and he's very careful in how he frames this. Because they were all posted at unclaimed S3 buckets. So all he had to do was claim the S3 bucket.
You can host something and then you can be like, domains, I control this domain now. Like, give me, oh my God.
I can be the CA. Yep. Yeah. Yeah. So we have substantially improved. There's fruit there. Low-hanging fruit there. I think that's still to be worked on. For CAs, the current requirements are a bit confusing, especially if you're not like enmeshed in this. And so there's still a lot of work to make the requirements clear. And that's something that I am excited for, that's going on in the CAB forum, of actually specifying, like, this is what a certificate looks like. We're not going to describe prosaically. We're actually going to show you like bits and bytes and tables and make your certificate match this. But yeah, I do think things have improved, but I think if anything, it's going to be more and more introspection on why exactly do we trust the auditor? Why do we trust the CA? And to be fair, auditors hate this just as much as CAs. And the reason auditors hate this is they're worried about the reputational harm of being found out that they're doing a bad job. So there are audit firms who've made very clear that if there are greater requirements on transparency, they will probably stop providing audits to CAs because they don't want the reputational risk of the CA doing something bad or being challenged by members of the community who say, like, hold on a sec, how did you reach this conclusion based on this evidence?
So things are getting better, and they're getting better in X509 and /CAs than they are in the DNSSEC world, which I think will make Thomas happy.
I'm just sitting here moping.
Yeah, and RPKI is happening slowly. Job Snyder's or Yogi Snyder's, I'm terrible at pronouncing names. Someone active in the RPKI space. Turns out that RPKI implementations are terrible in their own right. And RPKI tries to give a lot of specificity, which is to their credit. Like, they cut off all the bells and whistles and knobs. It just turns out that implementations aren't actually enforcing that. So lo and behold, you're back to square one. But RPKI is happening, and that will do a lot for some of these BGP hijacks and some of this nonsense. And hopefully ICANN will continue to improve its registrar accreditation program and look at strengthening security there, because that remains a weak link.
Do you have comparable influence over registrar and registry security than that you do over CA programs?
Again, there's the you guys
Adobe, I'm
question,
sorry.
which ICANN is an interesting organization. I think there are a lot of truly influential and respected people who do have a lot of influence at ICANN. If you look at the Security Stability and Advisory Committee, the SSAC, you'll find a lot of tech luminaries there. Warren Kamari, is on that group. You'll find a number of other people. So I think there is some influence, but I would say that there is perhaps not as ICANN, of course, has the influence. I probably shouldn't get into a whole lot of politics on ICANN, other than there are some fascinating reading, on the politics of ICANN from some of the MIT press publications. Like I can provide some links for. But yeah, the registrar security, I don't think will as improve as quickly as, say, the web PKI has improved, unless ICANN really, really cracks down. However, that's also not going to help for CCTLD. So I think if you're a site, certainly you should be incredibly wary of the use of CCTLDs, because CCTLDs are treated as basically sovereign territory, whatever that country is. And so they don't apply. They don't have to follow anyone's rules. They're doing their thing on the internet. It's sovereign territory. And so you find a lot of the CCTLDs having very poor security standards, or just doing things that are, say, actively harmful to stability. So be careful about your .fi or your
Are you telling me that the domain I own, secure.af, might not actually be that secure?
It might not be that secure.
Awesome.
Yeah.
It's Afghanistan, so it's got its own set of political issues right now. Like that this is very low down on the issues with Afghanistan right now, but we'll see what happens to their DNS registry.
Yeah, as you said, there's a lot going on there. Yeah, so sorry. I mean, I realize we've ranted about a lot of things, or I should say I've ranted about a lot of things. I'm optimistic. I'm optimistic for the future, though, and there are a lot of great people, and we've lost a tremendous influence. Jerv Markham, who used to be at Mozilla, was just a profound influence in truly improving things and shaping things up as a very modern voice. And he passed away a few years ago. But I am encouraged to see that there are a lot more people getting involved, and this is where I get the plug, which is, if any of this is exciting, hanging out on Mozilla's dev security policy list, which they run as the public list and have done since they introduced their root program, to have these discussions. The questions are like, what did it take for David to be an auditor? This was something that was discussed, back in 2008, because it used to be that web trust wasn't the only audit standard. There were a lot of audit standards, and there were a number of folks who did not use any of web trust or Etsy who were incredibly competent and, proficient at auditing. And times change, risk models change, and they became web trust accredited because that's what you do. But there's a lot of welcome feedback.
Yeah.
Andrew Ayer is another person who's very prolific on that forum and truly kicking butt at taking a detailed look at sort of what the claim CAs are making, whether it be in their incident report or their sort of policy statements, and saying, do you actually do this? You say you do this, but do you? And there's, huge value in that. And we've seen, like, I guess where I was going with this is, over the past few years, there has been an increase in participation, which is really encouraging. You're going back to, Deidre's butts question, is that's the best way to help me, win my scratchers, is start hanging out on these forums and start getting involved, because you can become the next me, or better than me, or something. I'm not sure what the pitch there is.
You can contribute to Zealand.
Yeah, there's a lot of opportunities. Yeah. This was fun times.
Thank you so much, Ryan.
And just one last question to close out with. How many airline miles does your dog have?
Hers has expired. She used to pull like 60
Damn.
to 80,000 miles a year with me, but pandemics
they should have
being
extended her
pandemics,
status.
no more frequent
They
pup
did it for a
status,
lot of other
right?
two-legged people.
Yeah, JetBlue used to have a program where your pet could earn miles on every flight.
That's amazing.
300 miles. And it was the Jet Pause program.
Ryan Sleevi, thank you so much for
Ryan, thank you.
chatting.
Thank you.
Thank you. Good luck
Yeah.
editing this. I'm sorry for the leg.
We'll figure
Fun
it out.
times.
Thank you very much, Ryan.